There is a very well-known diagram called the Hertzsprung-Russell diagram, or we just call it the HR diagram, and the most important diagram in astronomy. It shows how stars change over time, and it shows the relationship between luminosity, surface temperature, and the radius, also known as the magnitude of the stars. So this diagram, as you can see here, has a lot of information on it. So it takes a little while to get familiar with, but what's great about it is it shows so much in one graph, essentially, but with multiple variables. So here you can see a large path that goes across diagonally on the chart, and it's got colors, and it says main sequence, and here you have more red stars, yellow stars, white stars, up to blue. And you can see that the higher up in the chart, a lot of times the larger the star is. So we have supergiants over here. Um, Sometimes you can skip over to a phase of stars just called giants. Our star is roughly around here. There's the sun. So you can see how it compares to a lot of other stars. And here is a separate branch of stars called white dwarfs. So this is a little bit better diagram, the one from your book. It's not as fancy and hard to read. There's tons of these that you can go and get offline if you want to look at different ones, but this one keeps it nice and simple. So here you're looking at star color along the top. You're looking at surface temperature at the bottom, and then your brightness, which isn't on this diagram like it was on the other one, or luminosity, would be along the side. Okay, so this allows you to make some comparison between stars. We're going to talk about some of the vocab real quick, and then we'll come back to this picture and see how it all. All right, here's some of the vocabulary that you will hear when we're talking about stars. Color is color, but what's good to know about it is that the reddish stars um, are usually cooler, and the bluer stars are usually hotter, which kind of goes against what we think about with warm and cool colors. But you can also have yellow, bluish white. So there's degrees of going from red to blue. So temperature, like I just said, those cool stars are red and blue stars are hotter. The size of stars appear to be all the same size from Earth in most cases, but many are larger or smaller than our sun. The size of the star depends on many factors. We also have the chemical composition of stars, and there's different elements that make up stars. So the vast majority of stars, though, like our star, are primarily made of hydrogen and helium. So there are two types of brightness, and they don't do this just to make it confusing, but it's a different way to describe stars. And brightness is one of the things that comes up quite a bit, and it's important that you know this. There's what's called the apparent brightness, and that is a star's brightness as it appears from Earth. So if we're looking up at the sky, we can categorize the stars based on how bright they appear to us. However, the absolute brightness is used a lot in astronomy, and that's the star's brightness compared to other stars if they were all at the same distance from Earth. So there's a lot of stars that don't appear as bright as our sun, but if we were to put it at the same distance from Earth that our sun is, it would be significantly brighter. Hopefully not also larger and vaporize us. And the last term down at the bottom is luminosity, which will come up a little bit probably later on as a way to talk about how much energy is given off by a star. When we think about luminosity, usually we think about it being bright. So you'll hear the term used as brightness, but in astronomy, luminosity really is the total amount of energy given off by a star. So if we look at the chart here, and now I was able to get absolute brightness on there, we have these three variables, and you can see down here at the bottom, the hotter stars, 50,000 degrees, are over here in blue. Blue or white, they're getting cooler, and then their absolute brightness. You have really high, bright stars, and they can be blue and hot, but you can also have really high brightness stars, but they're actually cool in temperature, like Betelgeuse over here, which only has a temperature of 3,000 degrees Celsius only. So our star is a main sequence star, and it's just kind of hanging out in the middle of the chart. It's a medium brightness star. It's a medium temperature star. Um, so it's nothing super special, although it does allow us to survive. So that's the HR diagram and a lot of the vocabulary needed to help classify, categorize, compare and contrast stars. So take a look at it, get familiar with it. It is something that's very important in astronomy. So have a great day.